Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Basics, Trigonometric Functions. Concept number 21. The secant of 30 degrees, 45 degrees, and 60 degrees. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. What we're doing here is super effective. I'm coaching you to turn your wants and desires of getting an A or perfect test scores into a brand new paradigm. I want to include everyone who needs a boost in Algebra 2. And if I could stick every single math student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I probably would. So inbox me at memedicine@gmail.com to get your healthy dose of Algebra 2 by ordering the complete Cram session beyond the trigonometry series. You have lots of peers, classmates, and colleagues who could really benefit from this Cram session as well, so be sure to tell them to inbox me at memedicine@gmail.com so that they too can order the complete Cram session. You'll be glad you spread the word because they'll make great study buddies. And last but not least, the concept of cramming often has a negative connotation. But what people are actually thinking of is hurrying, which is a result of fear and can consequently be destructive. We're not hurrying here, we're cramming, and there's a huge difference. Hurrying is jam-packing tons and tons and tons of unorganized information into your mental DNA over a tiny amount of elapsed time, whereas cramming is taking quantum leaps in your understanding in an organized way in what seems to have been an instant. So let's delve into the concept of the secant of 30 degrees, 45 degrees, and 60 degrees. The secant of 30 degrees, 45 degrees, and 60 degrees. What are the exact values of the secant of an angle theta when theta is equivalent to 30 degrees, 45 degrees, and 60 degrees? I'll give you a moment to think and definitely press pause if you need to. All right, so hopefully by now you are able to press pause and arrive in an answer, but if you didn't, that's completely fine. Let's attempt this together. Okay, so before expressing the exact values for the secant of 30 degrees, 45 degrees, and 60 degrees, we need to understand the concept of standard position. I always struggle with saying position. Doing this is going to simplify finding all trigonometric values, okay, including the secant. And because 30 degrees, 45 degrees, and 60 degrees are acute angle, which you're going to see are in standard position in quadrant 1, these specific angles are going to have 7 key features according to the standard position concept, okay? All right, so the first feature is that the origin of each of these angles is located at the vertex of each of these angles is located at the origin. It's important for you to know that the origin has a coordinate location of 0 in the x direction and 0 units in the y direction, right here, okay? And the ray on the positive x-axis, which you may be able to tell is slightly bold, it's going to be called the initial side ray. The other ray terminates in quadrant 1 after theta grows in the counterclockwise direction, and this ray is called the terminal side ray, but we're going to be cute and call it R for short, okay? Now, we're going to transform this ray into a segment length, and the way we do that is by introducing this point. We're going to call the point P being short for point, and P has the coordinates X and Y, okay? All right, so this is the fourth feature, transforming this, well, pretty much this is standard position without the point, but we need to introduce this point to meld the concepts of coordinate locations and trigonometry, okay? And so obviously, for our purposes, we're going to resolve this newly formed segment into its components, its horizontal and vertical components. And so the horizontal resolution of the R segment, is going to be x because it goes to this extent in the x direction. And the vertical resolution is going to be y. The vertical resolution has a value of y units because the segment extends up in the vertical direction y units, okay? All right, so yeah, that was like features 4 and 5. Well, maybe 5 and 6 actually. And what I want you to notice is that although the extent of this ray is positive x units in quadrants 1 as well as in quadrants 4, if the terminal side segment ended in quadrant 4, it would be negative x units in quadrant 3 and quadrant 2, okay? And we could say the same for the y resolution or the y coordinate of the segment length. It's going to be positive y units if the terminal side segment terminates in quadrants 1 or quadrants 2, but it would be negative y units if the terminal side segment terminated in quadrant 3 or quadrant 4. Now, we know the numerical caveats with the x and y coordinates of this point P, but what about R? What about the segment length? Well, what's interesting is that this segment length is never going to be negative at all because in order to determine its magnitude, you have to use a variation of the distance formula. Instead of D, we're going to say that R is equivalent to the square root of the x coordinate of P squared plus the y coordinate of P squared, okay? So you can see here that squaring undoes any negative signs you might encounter for having the terminal side segment terminate in any of these other quadrants. But we don't even really care about them because remember I told you these are all acute angles. When I say acute, they grow in the counterclockwise direction, but they are bound between the quadrantal angles 0 degrees and 90 degrees. Now, when I say quadrantal angles, I just mean that the terminal side ends on one of the x-axes or y-axes. So some quick examples of, this is an aside by the way, quadrantal angles are 0 degrees as I previously mentioned, 90 degrees as I previously mentioned also. We have 180 degrees, 260 degrees, 360 degrees, and if your angle is growing in the negative clockwise direction, that's right, I said it, the negative clockwise direction. One's mind would assume that going in a standard clockwise direction would be positive, but in coordinate geometry, it's negative. So you could have, again, 0 degrees, negative 90 degree quadrantal angle, a negative 180 degree quadrantal angle, a negative 270 degree quadrantal angle, and so forth, okay? Now back to what we were previously discussing. So the reason why this is a variation of the distance formula, because the distance formula says that D is equivalent to the square root of the final x position of a segment length minus the initial x position. Well, our initial x position here is 0, so we don't need to be redundant and write it. You're going to square that difference plus the final y position of the segment length minus the initial y position of the segment length, which is also 0. Again, we don't need to be redundant and write y minus 0. And then you square that difference as well and take the square root, okay? All right, so basically the secant of 30 degrees, 45 degrees, and 60 degrees depend on the fractional ratio of the y coordinate or how much the segment length traverses in the y direction and the segment length. Okay, so in order to figure out this, we would have to compare these two values, okay, which are again are going to be positive because we are located in quadrant 1. Might not be the case if we're located in other quadrants, okay? All right, so yeah, let's just get into it. Oh, and basically, the secant of any angle theta is just the reciprocal identity of the cosine function, okay? And so the cosine of any specific angle theta is going to be equal to, oh, I had said y, the y coordinate, I actually meant x. So we're comparing how much this segment length traverses in the x direction to the actual segment length. And note that, yeah, you guessed it, the segment length is going to be the hypotenuse of what is actually a right triangle. Let me specify that for you. After resolving the segment length into its x and y units, we develop an imaginary y triangle. And this is basically the basis of finding all trigonometric values, whether it's cosine, sine, whatever, in Algebra 2, okay? It's this triangle here. That's why we needed to introduce this point P on the terminal side ring. All right, now back to business. So yeah, we know, and especially if you order the complete cram session, you should know that the cosine of the specific angle theta would be its x units traverse divided by the hypotenuse, okay? So for 30 degrees, which you should have memorized, we'll get into that. And then again, I said the secant of an angle theta is just going to be the reciprocal identity of the cosine. So all we have to do is flip the fractional ratio, and we wind up that the secant of any angle theta is going to be the hypotenuse length divided by the adjacent side, or the x-coordinate resolution of this hypotenuse length, okay? All right, so let's first tackle the cosines, just, for, as a reminder in case you forgot. So the cosine of 30 degrees is the square root of 3 over 2, okay? The cosine of 45 degrees is going to be radical 2 over 2. The cosine of 60 degrees is 1 over 2. And notice that basically the denominator, or r, has a value of 2 in all these instances, okay? Which is kind of neat. And so, yeah, the secant of 30 degrees is going to be 2 radical 3 over 3. And just hold your horses, because I know you might be wondering, well, excuse me, how did this happen? Well, I told you before that the secant of an angle theta is a reciprocal identity of cosine. And when you flip cosine of 30 degrees, you're going to end up with 2 over radical 3. Well, radical 3 is an irrational number, meaning that it's going to, when you try to evaluate the square root of 3, you're going to get a decimal number that never terminates. And in the world of math, they just don't like that for some reason. So we use a technique, this is an algebraic technique called rationalizing the denominator, where you multiply the fraction by 1. But the version of 1 that you're going to use basically is the radical divided by itself. And so when you multiply a radical by itself, you're essentially squaring it or getting rid of the square root. So you end up with 3 in the denominator. And then you end up with 2 radical 3 in the numerator. Hence, excuse me, I'm a little hoarse today, we have our answer, okay? Now, let's see. The secant of 45 degrees is going to be radical 2. Again, we arrived at the, because I know you might be thinking, well, 2 over radical 2 is the reciprocal, the exact reciprocal. But again, we don't like having irrational numbers or square roots that never terminate when you evaluate them in the denominator. So we use the algebraic technique of rationalizing the denominator. And since the secant of 60 degrees is going to be the reciprocal identity of the fraction 1/2, that's obviously going to be 2. No rationalizing of any denominator needs to take place because the square root of 1, yeah, actually, the square root of 1 and 1 is actually like the same value. But when you evaluate 1, it's rational. So yeah, you don't need to do anything with that, okay? All right, so basically these are our answers for the exact value of the secant of 30 degrees, 45 degrees, and 60 degrees. All right? Okay, thanks for tuning in. And intellectual comprehension of this material was not difficult at all. And after the short amount of time it takes to complete the entire cram session, you'll be prepared to answer a battery of questions about any Algebra 2 concept, okay? So definitely inbox me at memedicine@gmail.com to order the complete cram session.